Welcome to the Getting to Know Network Monitor lesson. In this lesson, I'm going to show you where it's appropriate to actually capture the data packets from. And you're going to see when there's just two machines, no big deal, but when you throw in a couple more machines, it gets really interesting fast. Then, one of everyone's favorite topics, of course, is documentation, but I'm going to show you how you can save your own sanity when it comes to walking through these network captures that have thousands, sometimes tens of thousands of data packets in each one. So I'll show you what the important information is to document. Then, before we actually capture the data, I'll show you how you can kind of customize what data or how much data is captured. And once we have some data, I'll show you how to customize the user interface. You can move things around a bit, add additional information from the data packets, and remove information that you're not interested in. Next, I'll show you how to make sense of the captured data. Here, I'm just going to show you a couple of tips that make it a little bit easier to glance at the captured data and get a more rounded view of what you've actually captured and kind of help things stay straight. After that, I'll show you how to get even more information out of the data that's captured, not just the default frames. And the last thing we'll cover in this lesson is how to view specific frames in an XML format or in a window by themselves. First, we need to talk about where you're going to take the capture from. Now, when you only have two machines, it's pretty easy. You can take the trace on either machine if they're communicating with each other. Or there are times when it may be necessary to actually create two captures, one on either machine. Think about this. When firewalls are on machines, wouldn't you like to capture if the data is actually being transmitted across the wire? So you'd want to know that it left one machine, no outbound rules, drop the packets, and that it actually came into the destination machine so that there were no inbound firewall rules preventing the data from entering the machine, coming up the NIC, the network stack, and going into your applications. So there are times where, even with two machines, you might have to take multiple captures. And then it gets really interesting. In real-world scenarios, I have had to troubleshoot and capture data on multiple continents. So trying to capture data from one machine, out that firewall, into an internal firewall, then on the other side of the firewall, coming out that external side, and then into, and in this scenario I'm using an Exchange server, actually into the Exchange server. In this scenario, I would take four traces. I would take one on the Windows 7 client's network interface, another on the internal side of the firewall, a third on the external side of the firewall, just to make sure the firewall itself is not processing or dropping packets based on rules that possibly someone else set up and you're not aware of. And the fourth one would be the inbound network adapter on the Exchange server. This way you can find out if the packets left the Windows client, did they traverse the firewall, both internal and external adapters, and finally, did they reach the Exchange server. In scenarios where you have multiple machines that might be spanning time zones or continents, you really do need to create a cheat sheet. I know nobody likes to document. I understand that. But some of these issues can take you days to figure out, even weeks. Some traces that I've seen had hundreds of thousands of packets in them. And if you didn't document what you were looking at in that project, what the issue was, then every time you came back to start troubleshooting it again, you had to start from the very beginning and refresh your memory as to, now what was the problem I was having in this trace? So you want to record your issue. You also want to jot down the interesting IP addresses that you're looking for the information between, and then possibly packet numbers. If you've already looked at packets between 1 and 5,000, you might want to jot down that you're at packet 5001 this time. This is what I mean. It's not hard to document your captures. Let me show you. I'm on my WBC DC1. I also have my second domain controller, WBC DC2, up and running. They're on the same subnet. In fact, this guy's IP address is 51, where DC1 is 50. We'll start a network monitor trace. We'll open it up, choose a new capture tab, select Start, and then we need to generate some type of traffic. So one thing I'm going to do is I'm going to kick off another virtual machine. Get back to full screen on my first domain controller, and we'll open a command prompt. I am going to map a network drive just to generate some traffic. And that command completed successfully. We'll close the command prompt window, and we've got a little bit of traffic generated in here. Now, some of the things that you might want to jot down. Let's say that we tried to map a network drive, and for whatever reason, we were not allowed to map the network drive. Maybe we received access denied. So the data packets you would be looking to for mapped network drives actually begin with SMB, small message block packets. So I would open a Notepad doc, and I would simply say network drive mapping, error message, access denied. Of course, ours worked, but I did need to get some traffic in here before I could show you anything else. So we would say that we had access denied, and then we would list the source IP address. That's going to be 10.10.10.50, and the machine we were trying to map the drive to would be our destination IP address, and that guy's IP was 10.10.10.51. Now sometimes I even go as far, depending on how detailed the issue is that I'm having, if there's multiple machines in between these two guys, I draw out a little picture, just a graph, very rudimentary, so that I can glance at it and kind of get an idea as to what should have happened, and also put a little X mark where you think the problem might reside. And that's all I'm talking about for setting up documentation or creating a cheat sheet. Just so when you come back and look at this later on, you don't have to go through the whole trace saying, well, gosh, what was I doing this for? And what was the problem? And what was the error message? This is going to make it clean and crisp every time you sit down to start troubleshooting this issue again. For now, I'll minimize that Notepad file. And that's it for documenting. Nice and easy. Now, you can also customize the data that is captured by choosing a parser profile. There are only 5 by default. You can create your own as well, but I wanted to show you what these mean. The first parser profile is called Pure. Well, this doesn't actually do a lot of parsing. It gives you very, very limited filtering. It is the most basic capture that you can create. The second is the high performance capture profile, which will provide you some optimized filtering speeds, but the filtering capability is limited to just TCP and UDP protocols. So here you wouldn't get anything like HTTP. You would get any protocols that are related to TCP and UDP. What you'll find on most of these parser profiles is you can either dial it so you get a lot of detail about the data packets that you're getting, which is going to slow down the trace and take longer to generate the view every time you open it up, or you can roll it back and say, show me the data you've gotten really, really fast, but you won't have as much data. The faster parsing parses more protocols than HPC, so you'll get more than just TCP and UDP. Some of those would be like ARP, HTTP, DNS, and NetBIOS name resolution. But you don't get the big heavy-duty protocols like SMB and SMB2, which would indicate drive mappings or connecting and doing file copies from one machine to another. The default, and yes, this is the one that is chosen by default, the default parser profile will parse all the previous protocols we mentioned, as well as SMB and SMB2, along with RPC. The Windows this guy parses everything. It's every Windows-based protocol plus some of the SQL protocols that are thrown in along with it. So the Windows parser is the one that will give you the most information about every single frame of data, but it's going to take a little bit longer for it to parse the information and display it for you. I'll show you how to change these in just a second. Once you have data, you can customize the user interface. You can undock and dock the panes. Remember the panes we looked at? There was the network configuration pane, the frame details, the frame summary, and the hex details by default. There are other panes that we can open up if we choose, or move them around. So we can make some panes disappear, make them reappear again, and if you've mucked around with it so much that you don't know how to get back the original and all you want to do is start from scratch again, you can always get the default display settings back with just a couple clicks of the mouse. The layout of looking at all the panes, well, that can be changed as well. You can change the layout to be a simple, a diagnostic, or developer. You can also restore the default layout. Let's take a peek at customizing the user interface. Back on that domain controller, I'm going to stop the capture. And you can see we've got a little bit more data. We have about 263 frames that are being displayed, and we can see here that that's the same number that were captured. We've got our network conversations listed over here between the two machines. I'm going to go ahead and close that window. But I want to start with showing you parser profiles first. This you would set before you begin your trace. Your network monitor parsers, this is where you'll find the high performance capturing, default, faster parsing, and Windows. You would simply make your selection and then start the trace. So this is going to dictate the amount of data you get for every frame that's captured. I'm going to leave it as the default. Next is undocking or moving around the panes. So notice the panes that I have here. I've got the display filter. I have the frame summary, my frame details, and my hex details. Let's go ahead and close down the display filter. We're not really going to use that in this lesson. That'll be in the next lesson. But what I might want to do is undock the hex details. So on this, I can highlight the tab, press Shift, click, and drag it to wherever I want it to be. If you drag it and undock it, then you've got it listed as just a floating window. So you could move this around to wherever you wanted it. And you could do the same with any of the panes. To get back to the default again, you would go under the View menu and choose to restore the default layout. That's the quickest and easiest way to get all the way back to the defaults. Now that takes us to the layout of what we're looking at here. So this is our default layout. If you just want to quickly and easily change the layout, you've got the few here to choose from. We're looking at the simple layout now. If you want to look at the diagnostic layout, which this is the one I work in most of the time because you want to see the frames, as many of them as you possibly can at one time. A different layout you can choose is the developer layout. So notice how it kind of moves the frames around for you. You might find one that you like all by itself, or you might decide, I don't use network conversations very often, and I don't use the display filter. So we'll just have the 3 up and running. If you decide that you want to get just one of those back, you don't want to go all the way back to the default settings again, you can choose View and choose to bring one of them back. And then you can move that around to wherever you would like to dock that pane. So we've set our layout to the developer layout, gotten rid of that network conversation window, and if I do a save as, I can choose to save this as cap 3. When I close that down, open cap 3. You can see I've got a couple others I've been playing with. Doing a save as will actually save your format or your layout of the screen as well. If you just close Network Monitor and allow it to do a normal file save, it will set everything back to the default layout. So if you want to keep the layout, go ahead and click Save As instead of Save. That's how easy it is to customize your user interface. There are quite a few things you can do in addition to that, which we'll see in just a few minutes, but you can see how easy it is to get things where you want to use them and see them. It might make it easier for you to troubleshoot issues if you can design that user interface a little bit better to what your needs are. Making sense of the captured data. Well, IP addresses are going to be in there that identify machines, but as human beings, we don't really walk around saying, hey, how's 10.10.10.50 doing today? We would say, how's DC1 doing, or DC2? So we really don't think in terms of numbers, but we think in terms of names. So sometimes it's easier to turn those IP addresses into names, and maybe not even the name of the actual machine, just a label that you want to give it, like this machine was the client and that machine was the server. So a lot of times I'll create client and server as the names of the machines. To do that, we create an alias. You can also create an alias list, save it, and then open that same list in multiple traces and think about how many domain controllers you have. How many Exchange servers do you have? How many SQL servers? You could set up your aliases one time for all your servers, save that list, and then every time you have to do a network capture, you can open that list of aliases, which is whatever label or name you've associated to an IP address, apply it to a new capture, and it will go in and change all the IP addresses to be represented as the name or the label that you've given it. So it's nice to be able to create that list one time and use it in multiple traces or captures later on. One of my favorite tips or tricks is when you're in a really large environment. And in the environment I have here, I have 5 Outlook clients and 1 Exchange server. Think about your real-world scenario and layout of your network. You might have 2 or 3 Exchange servers and hundreds, if not thousands, of Outlook clients. Well, if you're having one Outlook client that's having a problem with an Exchange server, how can you quickly focus in a capture on that specific Outlook client and a specific Exchange server? I like to refer to that kind of as finding the needle in the haystack. And this is what I mean. In a typical environment, you've got data packets coming in from all sorts of machines. Servers are talking to each other. Domain controllers are talking to servers. Everybody's talking to everybody. So the data as it comes in might just look like a packet after a packet after a packet after a packet. To help you find that needle in the haystack or focus on the traffic from one specific client, one of the tips I like to use is to ping. Let's say you're having a problem with an Outlook client who cannot get his email from the Exchange server. So from the client, I would ping the Exchange server and then attempt to get email. When it's done and I had the error message on my screen, I would ping the server again. This way, I'm using ping packets as bookmarks in my network trace. So now, even if I have 10,000 frames in this one capture, I can quickly and easily go find the packets that I'm interested in troubleshooting. So always try to use ping packets just to bookmark where you are in that network trace. And we've seen the default columns of information that you can get about each one of the frames. But there are some columns that you might not need to use, and they're just wasting space. And then there are a ton of additional columns of information you can bring in if you would like to. There are some built-in column views for most commonly troubleshot issues like HTTP and TCP. You also might want to add some columns that can help you in that scenario that I showed you a little bit earlier, where we had multiple machines. We had a client and a server, and in between that we had a firewall. So when you do have multiple captures, there's a very specific column of data that I like to add so I can follow that data from one machine to the next, to the next, to the next, and I just refer to that as follow that packet. You can also save the new column settings or revert back to the default column settings anytime you need to. Once you find that needle in the haystack or the exact frame that is showing the error message and what your problem is, you could pull that frame out. If it's a range of frames, 2 or 3 altogether, you could pull those out and view them in their own window so you can troubleshoot just those specific frames. You can also view the frames in an XML format. If you wanted to import those XML frames into another application, so you could possibly create a different view of the network trace, like a pie chart or a bar graph, putting them into Excel. Let's take a look at additional information we can put in the columns and how to view frames in their own window. Back to our capture. Again, I'm going to get rid of the display filter, get rid of the network conversations. We really aren't interested in that information yet. What I am interested in is looking at the source and the destination machines. Well, I've got the computer names here. They're both domain controllers. So how can I identify which one I actually did the net use statement on and which machine was the destination machine that I wanted to connect to? I would create an alias. To create an alias, I'll go to the drop-down menu under Aliases and choose Manage Alias. Then I'm going to create a new alias, and this is how you would create your list. The address is 10.10.10.50. The name, this is the one I initiated the conversation from, so this is my client. If I wanted to input comments, I could do that as well. I could type in map network drive and choose OK. As you can see, I can create as many aliases, and you wouldn't create multiple aliases for the same IP address. You only create one alias for each IP address. But this is how you could save this list, and then every single time you open or create a new capture, you could open this list and then automatically apply your aliases to the existing capture. Now, because I'm actually creating the alias in the original capture, then it automatically changed that WBCDC1 to client. Let's create another for server. Choose new, 10, 10, 10, 51. This is going to be server. No comment that time. Then we can close. And notice what you're looking at here. This is the client packet. This is destined to the server. Now, it might not seem like a big deal, but when you do get into some great big traces, it's going to be so helpful to go ahead and label these guys so that every time you open it to start troubleshooting again, it's set in your mind, this is where the command originated. This is the source machine. This is the destination machine, which was supposed to have processed it. So for aliases, when you get a new capture and you want to open that alias list, you will have to choose, first of all, we would save it. Let's save it just as alias. Then when you wanted to open it again, you would open. And when you wanted to apply, you would have to click to apply the alias to your existing capture. Just opening a new one would not automatically apply it. And I know it's a bit confusing. There are a number of times here where we're going to build things like filters, alias lists, and you create it, but nothing happens to your trace. You actually have to apply it to the existing trace in order for something to change. The next piece of information we're going to look at are these column headings again. Now, I mentioned these a little bit earlier, but what we have is the frame number, the order in which the frames were captured. The time offset, well, that's how long Network Monitor has been running in milliseconds before the frame was captured. The process that actually generated the packet. Here's our source machine, destination machine, the protocol name, and a description of the packet. We also have the conversation ID. Now, you can always get this information if you had left conversations enabled. So if on network conversations you already have this traffic generated, there's not really a great reason to keep the conversation ID because you can just come over and look at them. So we could right-click on that and choose to remove the column. I'm also going to close that guy back down. We can always open it up again. Just getting it off our display doesn't mean the data's gone. Some other things I might want to do. Well, the frame number, that's taking up an awful lot of space. The time offset, I'm not really looking for information to troubleshoot on that, so I could just close that guy down altogether. Adding columns to an existing capture can be very interesting and time-consuming. As you're going to see, there are hundreds, probably, of settings that we can choose to add to the column. So I can go to the column, select, choose columns, and look at all of these additional columns that we can input. There's tons of information that we can input. One that I like to input, especially when you're doing multiple network traces, and really when you're dealing with multiple time zones, it's so difficult to open the traces and try to find the data packet that goes from one machine to the next, to the next, to the next. So what I like to grab is the time of day column. That way, notice you can also rearrange your columns from within here, but it doesn't matter. You can click and drag them all over, so you don't need to come in here just to rearrange the columns. But notice now I have my time of day column. I want to put that frame back over there. Let's just move him back on over. The time offset, I'm going to get rid of that one. And notice now we have the time of day for when this data packet was actually captured. So using the ping method, where you first ping the machine that you're destined to talk to, find where those data packets start, look at the time of day, and then you can follow that time of day on each network trace, so you can actually grab chunks of data within 2 minutes on multiple network traces. So I love being able to add the time of day feature. So I've shown you how you can remove columns, you can rearrange your columns, and you can add columns. If you ever get to the point where you just wish you had the default column layout back, you can choose Restore Default Column Layout. Notice also, by default, automatically Save Column Layout is stored, so that when you do close Network Monitor, when you reopen it for that capture, you'll see the same column headings that you had when you closed it. The last topic was how to look at specific data frames in their own window or in a different format like XML. So if I wanted to take just this TCP traffic, let's grab that and these three. This is the conversation that happens between two machines anytime they connect to each other. So this is actually setting up the TCP session between those two machines. I could then right-click and choose to view the selected frames in a brand new window. Now, I could dig into exactly what type of information is in those specific frames. So when you're dealing with multiple traces, this comes in handy as well to be able to make sure that a TCP connection was made from client A to the internal side of the firewall, from the external side of the firewall to the Exchange server, to use the scenario that I brought in earlier for multiple machine traces. And close that window down. If I wanted to open a data packet, one or multiple, you could choose multiple as we just did, and tell it to parse the frame as an XML file. This is what your data packet will begin to look like. And you could then use that to import the information into another type of application for whatever your needs might be. But it's a quick and easy way to get your data frames in a different format. And that's how easy it is to create your own alias list. You can open it multiple times, modify or customize your columns to be whatever information you would like displayed, and how to parse your frames in XML as well as open specific frames in their own windows. What we covered in this lesson was where to take a capture. If it's only between two machines, that might not be a big deal. You might only need one capture, but you always have to take into account, do you have local firewalls running on those machines? And what happens when you have a corporate firewall running in between two machines? Now, to actually get a full picture of what's going on, you might have to have more than one trace. When you get into multiple traces, it will save you a lot of time and a lot of frustration if you take 5 minutes to sit down and just document what the issue is that you're troubleshooting, the significant IP addresses, and what data frames you've already looked at. You can customize the data that's captured by using a parser profile. Once you have data, you can customize the way the data is displayed in the user interface. I showed you how to undock one of the panes and allow it to be a floating pane. We also looked at getting rid of windows and then going back to the default layout. I also showed you how to make sense of the captured data by creating aliases, just little nicknames for the machines, and they don't really have to be the computer names, but I like to name them more the function. Is this the source machine? Well, that's going to be a client. Is it a destination machine where the destination machine is supposed to allow a mapped drive? That would be the server side of the house. We took a look at adding all kinds of additional columns that you could put in there and rearranging the columns. The last thing we finished up with was viewing specific frames in their own window and in alternate formats, XML in this scenario.